We are embarking on an incredible journey to the far side of the moon. We will explore China's Chang'e-6 mission and what the samples it will bring back from the moon's far side could reveal. Let's get started. Space exploration is a reflection of humanity's curiosity about the unknown and its desire to push boundaries. One of the most exciting areas of space exploration is the moon. The moon has been observed and studied for centuries, yet it still holds many secrets. China's Chang'e-6 CE6 lunar project is set to collect surface samples from the moon's far side and bring them back to Earth. This historic event could provide significant insights into the moon's development and the early solar system. The Chang'e-6 mission is named after the Chinese moon goddess Chang'e. China's lunar exploration program, marked by the Chang'e series, has achieved significant advancements in space exploration. These missions are part of China's goal to establish itself as an independent space power, and Chang'e-6 is a crucial step in this journey. Chang'e-6 is the first mission to land on the moon's far side, setting it apart from other lunar missions. The far side of the moon, often referred to as the dark side, has long captivated human curiosity. While we have gathered extensive information about the near side of the moon, the far side remains shrouded in mystery. The far side is markedly different from the near side in terms of surface features, geological structure, and past volcanic activity. Historically, the far side of the moon was the subject of many theories and speculations. In ancient times, it was believed that unknown creatures inhabited the dark side. Modern science, however, posits that the far side holds crucial clues about the moon's evolution and the formation of the solar system. The Chang'e-6 mission aims to uncover these clues and solve the mysteries of the moon's far side. The differences between the two sides of the moon have been a significant focus for scientists for many years. One of the most striking differences is the distribution of craters. The near side of the moon features vast volcanic plains and fewer craters, while the far side is densely cratered, suggesting different geological histories. Zhongyu Yue, a geologist at the Chinese Academy of Sciences, explains, "There are significant differences between the far side and the near side of the moon in terms of crustal thickness, volcanic activity, and composition." CE6 landed in the South Pole Aitken (SPA) basin, a unique terrain on the moon, and the samples collected are expected to help answer one of the most fundamental questions in lunar science. What geological activities are responsible for these differences? The Chang'e-6 mission is the result of years of preparation and technological advancements. It aims to be the first mission to collect samples from the moon's far side and return them to Earth. This mission required a sophisticated probe capable of landing on the lunar surface, collecting samples, and safely returning them to Earth. On June 2nd, CE6 landed in the Apollo crater, located at the edge of the SPA basin, the largest impact basin on the moon. The probe used drilling and scooping methods to collect rocks and minerals that might contain traces of early meteor impacts. These samples are expected to reveal how far debris from early collisions spread across the moon and whether there are differences compared to the asymmetrical near side. The technology used in this mission involved a series of meticulously planned steps. First, the landing site selection was crucial. The Apollo crater, situated at the edge of the SPA basin, is geologically intriguing and offers a perfect site to understand the far side's geological structure. The analysis of CE6's samples is eagerly anticipated in the scientific community. These samples, the first collected from the moon's far side, could provide vital clues about the moon's and the early solar system's evolution. Researchers hope that the CE6 samples will contain impact melts from the Apollo crater and SPA basin. This information will help clarify the role of early lunar meteorite impacts on the moon's evolution and be significant in analyzing the early impact history of the inner solar system. Yue states, "My greatest hope is that the CE6 samples contain some impact melts from the Apollo crater and the SPA basin, which can provide crucial constraints on the early impact flux of the moon." This information will help clarify the role of early lunar meteorite impacts on the moon's evolution and be significant in analyzing the early impact history of the inner solar system. The CE6 samples analysis could answer many questions about the moon's geological history. For instance, it could reveal why the far side of the moon has more craters, when and how volcanic activities occurred, and how early meteor impacts influenced the moon's surface. Lunar research is one of the most vital and exciting fields in space science. Explorations like these not only help us understand the moon, but also provide insights into the history of our entire solar system. The Chang'e-6 mission is a significant step in this direction. Following 10 successful sample return missions from the moon's near side, the CE6 samples from the far side are expected to contribute to a more comprehensive understanding of lunar evolution. The analyses to be conducted in the coming months and years will provide new and exciting information about the moon's and our solar system's early history. The success of Chang'e-6 will pave the way for future lunar and space missions. This mission holds great importance in terms of technological advancements and scientific discoveries. The data collected by CE6 will not only help us understand the far side of the moon, but also aid in developing new methods for exploring other celestial bodies. The exploration of the moon holds a significant place in the history of science. In 1959, the Soviet Union's Luna 3 spacecraft took the first photographs of the moon's far side, revealing striking differences between the two sides and generating great excitement in the scientific community. Subsequently, NASA's Apollo missions conducted manned landings on the moon, providing extensive information about the lunar surface. The Chang'e-6 mission continues this historic journey. Former NASA Administrator Charles Bolden remarked, "Missions like Chang'e-6 help expand our knowledge of the moon's and our solar system's history. These discoveries will inspire future space explorations." Renowned physicist and cosmologist Michio Kaku emphasized the importance of exploring the moon's far side. The far side of the moon holds many secrets about the early days of our solar system. The samples brought back by Chang'e-6 will be instrumental in unlocking these secrets. Astrophysicist Neil deGrasse Tyson highlighted the significance of lunar exploration for humanity. Solving the mysteries of the moon not only enhances our scientific knowledge, but also guides future space missions. Missions like Chang'e-6 are pivotal milestones in humanity's journey in space. Expectations for the moon's far side are high within the scientific community. The samples collected by CE6 could provide new insights into the moon's geological past and the early solar system. The far side's higher crater density suggests it has experienced more meteor impacts, which could help us understand early impact events in the solar system. The analysis of CE6 samples could also shed light on volcanic activities on the moon's far side. While the near side features vast volcanic plains, the far side has fewer such structures. This difference suggests that volcanic activities occurred at different times on the two sides. CE6 samples could help determine when and how these volcanic activities took place. The Chang'e-6 mission is not just about exploring the moon's far side, it also brings significant scientific and technological advancements. The advanced drilling and scooping technologies used in this mission have greatly improved the process of collecting and analyzing lunar samples. The data collected by CE6 will help us understand the moon's geological structure and provide a foundation for future lunar missions. These samples from the far side of the moon are generating great excitement in the scientific community and opening the door to new discoveries. As we follow this historic event, we are getting closer to uncovering the mysteries of the moon's far side. China's Chang'e-6 mission will create a significant impact in the scientific world and give us the opportunity to explore the moon's unknown face. The first surface samples collected from the moon's far side will provide new and exciting information about the early history of the moon and our solar system. Future lunar and space missions will be propelled by discoveries like these. The moon's far side will continue to be a major point of interest for scientists, and the discoveries in this region will play a significant role in humanity's journey into space. The success of Chang'e-6 will go down in history as one of the most important steps in this process. Until the next video, stay curious and keep exploring.